Hi friends, very good morning to all. Today we are discussing the working of an electric motor. Okay, so let's start. So we know that we can generate magnetic field around what? Around a current carrying conductor. Suppose this is a current carrying conductor and we know that there will be magnetic field lines around it. Okay, suppose this is a solenoid, then magnetic field lines, if current is passing through it, magnetic field lines will be around it. If it is north and this is south pole, then magnetic field lines definitely present around it. Okay, so then how electric motor works? That's the question. Okay, so basically in an electric motor, electrical energy electrical energy that is converted to what? Mechanical energy in electric motor. Is it? Our electric fan, refrigerator, grinder, mixie, everything works. This type of instruments, wherever we can find the conversion of electrical energy to mechanical energy, they works on the same principle. So we name that principle as Moto principle. What it is? Moto principle. Okay, so now we can go deep into that. Okay, first of all, we can go to the structure of that electric motor. These are two poles. Okay, north and south pole. Okay, this is north and this is south pole. Okay, so now we are placing an armature coil in between them. What we are doing? We are placing an armature coil and in such a way that it has the freedom to rotate. So here we have the split rings as well as brushes we have, okay, to ensure the rotation of the armature coil, or it is through this arrangement of split rings and brushes it's able to, this armature coil is able to rotate. So there a question arise, what's this armature coil? Okay, so what is this armature coil? It is simply this type of coil, this type of conductor in which electric wire is closely winded. Okay, electric wire is closely winded to this conductor, this type of conductor. This is simply armature coil. Okay, so we know that between the north and south pole there will be definitely what? Magnetic field lines. Okay, I'm representing it with blue color. That magnetic field lines will be present here. Okay, we know that. Now we are connecting this armature coil. Here we have this armature coil. Now we are connecting that armature coil to what? To a battery. Here we are connecting it, or we are providing current to this armature coil. Okay, now current flows through this coil. Okay, so what happens when current flows through a conductor? Yes, we know that when current flows through this conductor, magnetic field lines develops around it. Okay, now we have what? We have the magnetic field lines of between these permanent magnets, that is north and south pole. Between that there will be permanent magnetic lines. Now this armature coil, when we provide current to that armature coil, it acts like what? It acts like an electromagnet, because when the switch is on, this armature coil have magnetic field around it. That is what it acts like a permanent, not permanent, temporary magnet. So definitely field lines around this armature coil. So I'm representing that field lines in this way. Okay, in this blue color, there will be magnetic field lines around this armature coil. So this is armature coil, current is passing through it. So field lines are generated around it. So I am representing that in this way. So it is in between this north and south pole of the permanent magnet. So this field lines between north and south pole will interact with what? The field lines of this armature. Okay, that is the field lines between this permanent magnetic poles, that is north and south poles, will interact with the field lines generated from this armature. Okay, so they will interact. So what happens when they interact? Here this field lines and north and south pole permanent magnetic poles, there will be field lines. So they interact. Okay, and as a result, what happens? A force is generated, and with that force, a force is generated, and with that force, what happens? With that force, the armature, it will rotate. Okay, the armature coil, it will start to rotate. Here we have north and south poles, and when we applied current to the armature coil, and already we said that that armature coil, it is what? It is in a position to rotate. We are giving that freedom to it with the help of split rings and brushes. So it will rotate with a force. Okay, this is the basic principle of electric motor. Okay, so what's happening here? When this field lines between the permanent magnetic poles interact with the field lines of the armature coil, then armature starts to rotate. Okay, so rotation means mechanical energy. Mechanical energy is generated here. What we are providing? We are providing electrical energy from battery, and mechanical energy is the output. Okay, that's we notice that in the case of kitchen blender or normal mixie, there will be blade under it. There will be a kind of blade under it. Okay, so that blade rotate when we switch on. And when we switch on, what happens? That when it is on, then that blade rotates. That is mechanical energy is generated. So we can move to this motor principle. So all such equipments in which electrical energy to mechanical energy conversion happens works on the basis of motor principle. Okay, motor principle simply it is simply what it is. It is when we are here we have what? North and south pole. So when we are applying current to a conductor, here we have this armature coil. So when we are applying current to a conductor, okay, which is current to a conductor in a direction perpendicular to this, here this direction will take into account. Okay, this direction and this direction. Okay, when we are applying current to a conductor in a direction which is perpendicular to the magnetic field lines between the permanent magnet. Here we have 90 degree. Okay, here also we have 90 degree. Okay, so when we are applying the current in a direction perpendicular to the magnetic field lines between the permanent magnets, a force is induced, a force is generated. Okay, this is motor principle. So in order to know the direction of this magnetic field, then current, and the force generated, we use what? We use Fleming's left hand rule. What we use? Fleming's left hand rule that we will use. Left hand rule. So, this is, suppose this is your forefinger and this is your middle finger, forefinger, middle finger, then this is your thumb. Okay, they are mutually perpendicular. Okay, so this is the forefinger, this one forefinger, this one middle finger, and this one your thumb. Okay, so I am drawing that direction. Your forefinger, so you are holding your left hand in this way. Okay, in such a way that your forefinger, then middle finger, then your thumb in mutually perpendicular way. Then the direction of the forefinger represent the direction of the magnetic field. Then the direction of the middle finger represent the direction of the current that we are passing through the conductor and is perpendicular to this magnetic field lines between the permanent magnetic poles. Then force, the direction of force is perpendicular to both this force, both this magnetic field and current to this and to this. Okay, magnetic field, that is the force generated, that is perpendicular to this magnetic field lines generated between the permanent magnets, and the current that we are passing through the conductor. Okay, so it is mutually perpendicular. Okay, so this is Motto principle. So the same that we can observe, suppose we have, this is a circuit board and we are providing current here, and we have a switchboard. This is switch, this is a switchboard, and you are hanging a copper rod. This is a copper rod, the one in blue. Okay, copper rod, this is a copper rod, and we are placing that copper rod in a direction in this way between the U-shaped magnet. Okay, this copper rod, we can suppose we are hanging small copper rod. Okay, so small one, we are hanging it. Then this is the U-shaped magnet around it. This one is the U-shaped magnet. This is the copper rod. So now we are just on the switch, that is now the circuit is closed. Current will pass and it will pass through the copper rod as well. So in as current flows through this copper rod, what happens to this copper rod? Actually, it's a magnetic substance. When we pass the current through it, field lines are generated around it. So it will become an electromagnet, is it? Field lines are generated around it. Then we know that this is a U-shaped magnet. It has north and south pole. Definitely, there will be magnetic lines in between them, field lines between them. It will interact with with the field lines of this copper rod. Okay, so while they are interacting, what happens? This copper rod, it will start to deflect. Okay, suppose this is the copper rod, this one. Then what happens to that copper rod? It will deflect. Okay, so that is, if force is generated, a kind of force, it will start to generate inward in this copper rod. Okay, so this is the same thing that's what happening in our motor also. So here this copper rod deflects in that way. Suppose this is a copper rod and when current is passing through it, what happens, this current is flowing through it, it will starts to deflect because the magnetic field lines between this u-shaped magnet as well as the field lines that is generated between north and south pole of this copper rod interact, and when these two magnetic fields interact, the a force is generated in this copper rod. The same principle that we are that what happening in this motor. So this is north and south pole. So now I'm consolidating. This is the armature coil, and we have fixed the split rings as well as the brushes here uh, to give freedom of rotation to this armature coil. Now when I supply current through this armature coil in such a way that this is current I, so in such a way that the direction of current is perpendicular to this direction of this magnetic field lines, a force is generated, and as a result, this armature coil, it will rotate. So it will continue to rotate as we are as long as we are supplying this current to it. Okay, so the rotation sustains upward, up to which we maintain current in the armature coil. Okay, so that's all about this electric motor. In the coming classes, we will discuss how an electric generator works. Okay, electric generator works. Okay, so today in this class we discussed this motor principle, and one more thing that we discussed is what, Fleming's left hand rule. Okay, Fleming's left hand rule that we had discussed, that is this: hold the left hand hold your left hand in this way such that this forefinger and the middle finger and the thumb is in mutually perpendicular direction. Then your forefinger represent the direction of this magnetic field, and your middle finger represent the direction of this current, and the thumb represent the direction of the force that is generated. Okay, so if you really likes the class, please subscribe to our channel so that we can you get notifications for about the coming classes, and please mark your attendance by pressing the like button. Thank you so much. So we can meet in the very next class soon.